Thank you. So, as was said, my presentation will focus on a small-scale demonstration project, which we did the GEORIS. Just short overview of my presentation first. We will see just a little bit overview of our company, SIJ Acroni, which is a part of Slovenian steel group, and then generally about the GEORIS project. Then we will skip to the technology and demonstration and assessment, which we did within the GEORIS project. Then I will focus a little bit more about Acroni steel stacks, which was used for GEORIS pavers, and the mixture where we use geotechnology, geopolymerization technology, and scaling and testing, and we did some SIJ analysis, and for the end you will see also demonstration video. Sorry. So, as I said, we are a steel company. We are the biggest steel company in Slovenia. We are producing mainly stainless steel portrait plates and special steel portrait plates, and also non-oriented electrical steel. So, overview of how them.
At the base of the Alps lies SIJ Acroni, Slovenia's largest steel mill with over 700 years of tradition. As a company, we are committed to positively impacting our local community and protecting the beautiful environment in which we work and live. With over 1,300 dedicated employees, SIJ Acroni is not only one of the largest employers in the region, but also a global champion of innovation and progress. We pride ourselves on having unique employees with innovative ideas, entrepreneurial spirit, and strong professional skills. To empower young people, we are offering them the opportunity for career growth and development through a comprehensive system of intergenerational knowledge transfer and a wide variety of training opportunities. At SIJ Acroni, we have implemented a system of circular economy to support our efforts for sustainable steel production. 98% of waste generated during our production process is recycled or otherwise reused. All SIJ Acroni steel products have an extremely low carbon footprint and are among the greenest steels in the world. We achieve this by recycling steel scrap, which is carefully separated by chemical composition to minimize the consumption of additional raw materials. We use 100% recycled steel scrap and melt it in an electric arc furnace. The melt is alloyed and refined in the AOD or VOD converter. The heat is then cast on the continuous casting machine and cut into slabs, which are reheated in the pusher-type furnace and hot-rolled on the Quarto rolling mill. This is where the production path for plates and coils or sheets separates. The hot-rolled Quarto plates are leveled, trimmed, and cooled in the cooling beds. Next, they are heat-treated to achieve the required mechanical properties, which are controlled in our in-house laboratories. After heat treatment, the plates are leveled, cut, and shot blasted. Stainless steel plates are also pickled, washed, and dried. The finalized plates are then weighed and marked. Production of sheets and coils requires further hot rolling on the reversible finishing mill. Coils are then side trimmed and shot blasted to remove the rolling scale. The cleaned strip is cold rolled to the desired thickness. Electrical steel is also heat treated to achieve the desired electromagnetic properties and coated with an insulating varnish. Our product range spans from stainless, wear-resistant, high-strength structural and electrical to tool steel grades, which are used in the most demanding industries. Our goal is simple: to provide high-quality materials for a sustainable future and make a positive impact on the world around us.
Okay, and now I will move my focus to the GEORIS project. This project was co-funded by EU Raw Materials, and in fact we started the project in 2022, and it will be finished at the end of this year. The aim of the GEORIS projects is to transfer it into the RIS region a novel geopolymerization technology that would utilize industrial waste to produce construction material and also catalytic powdered, all exhibiting significant financial performance and also environmental advantage. We are international consortium of 11 partners from Belgium, Greece, Poland, and also from Slovenia. The coordinator of the project is Enalos. This is a Greece company, and KU Leuven is a know-how provider, and Slovenian National Geological Institute was responsible for the laboratory testing of the construction material. So, the small-scale demonstration project at the SIJ Acroni site was done within Work Package 4. As I said, it was led by Enalos and co-led by KU Leuven, aiming at demonstration and assessing GEORIS technology by applying the GEORIS geopolymerization technology and demonstrating its innovation possibilities within that part. Also at the SIJ Acroni site, one demonstration site was built. So the developed product were assessed according to the assigned use with relevant standards, and technical and also economic analysis produced product were performed, and an environmental impact analysis were done. So let's see which mineral waste stream were used. There were used two. We used byproducts from the Acroni site, and we also used copper secondary products. In our process, two different types of steel making slags are generated, and one is produced during the production of stainless steel in electric arc furnace, and in the secondary production, we further process it in a production plant, and we receive the steel granulates, which are returned back to electric arc furnace, and mineral residue. This is incoming, which we further use for different applications. Similar process we have for the slags, which are produced also in electric arc furnace, but during the production of carbon. Still, those chemicals, as their chemical composition is different, and we also process them differently, and on the end of the process line, we get also steel granulates, which are returned back to the furnace, and mineral residue, which is ERC slag aggregates, which is mainly used for the road construction. And to produce GEORIS pavers, we also use copper secondary products, which we got from one company from Belgium. As I mentioned before a little bit, those three wastes, or not waste, they are actually byproducts, have a different chemical composition a little bit, but however, mostly they are composed of calcium oxides, silicon dioxide, and iron oxides. So, how KU Leuven developed the recipe for the GEORIS pavers? First of all, what we used Acroni as a binder. Then we used, as I said, ERC slag as an aggregate, and coronel to mitigate the problems with the high calcium oxide content in the Acroni slag, and also to further bring the synergy to the project. So, to reduce the cost, we used unmilled eco-minute. That is advantage in the way of, as you know, that milling is very energy intensive process. So in order to reduce also carbon footprint, we use it unmilled, and also to get more production of it on the end of the day. So that was one, and we blended with the coronel and granulated blast furnace slag. Of course, the precursors were activated with sodium silicate solutions, and as I said before, additional optimization was made on quantity of sand, where majority was replaced with EFC slag aggregate. So, upscaling, that was the next step after developing the right optimized recipe. So, two different dimensions of GEORIS pavers were produced: 40 by 40 by 4 and 40 by 20 by 2. And you can see on the picture there is kind of a mobile unit. As you can see, it's quite simple mobile unit. So actually, for the production of GEORIS pavers, you don't need a big equipment. It's quite easy for process in the way of airplane kits. So the most demanding thing indeed is utilizing the mineral and the residues with biopolymerization technology. Of course, this was to obtain the proper recipe. So first step was preparation of all the material which we have to use it. As I said, Acroni eco-minute, Acroni EFC slag, aggregate, coronel, red granulated blast furnace slag, and we mix it in a mixer, and later on we added alkali silicated solution, and we then cast it in different pots. Where pavers blocks were used, we decided to renovate the bicycle shed in the parking area of steel mill. The bicycle shed was really in bad condition, due mostly swelling of the subgrade material. Cracks appear on the bicycle area, and the Slovenian partner, which was also involved in the project, GGD, excavated all the subgraded material and replaced it with the EFC slag aggregate fraction 0 to 45 millimeters. Just the upper layer sand was used. So then last step was laying GEORIS pavers, which was also done by construction company on it. Next step was testing of GEORIS pavers. As you know, the construction sector in Europe is strictly regulated by the construction product regulation, which set technical requirements and legal procedures for replacing construction product legally on the EU market. This strict regulation aims to ensure the safety, stability and sustainability of products. In the most cases, products are tested following by harmonization EN or EID procedure. The alkali, the activated materials, for the data materials, there's no such documents. So for their technical evaluation, provision from standards for concretes were used in our case. In present case of alkali activated pavers, when product is ready for the market, procedure for European technical assessment or national technical assessment will be followed. As you can see, the GEORIS pavers have been subjected to extensive laboratory testing. Several tests were performed: slip and skid resistant, abrasion flow resistant, freeze throw resistant, also release leaching of the dangerous substances were evaluated. And why is this such extensive testing needed? Because construction material must fulfill their certain health and safety requirements through their life cycle. So, short overview of GEORIS pavers properties. As you can see, GEORIS pavers have good mechanical properties and also excellent durability. For example, here at the beginning, you can see that the bending strength, for example, it's even higher as for a commercial product, for concrete pavers. GEORIS pavers are also resistant to freeze, also in the present of the icing, whereas commercial products are not resistant. So regarding the bleaching, mostly we met the criteria for inert material, except the limit was exceeded for molybdenum, but it was not a lot, a little bit less than twice higher as the feasible limit. However, you still have to aware that the permission limits for a non-hazardous material is 10 mg per kilogram. However, regarding the leaching, we decided that we will perform some additional testing. So we will try to find the main source for molybdenum leaching, and the step which will be followed will be the optimization of the GEORIS recipe. Application will be also tested, confirmed, as I said, by demo installation through the time. Those tests will be continued also after the official end of the GEORIS project. We, SIJ Acroni, will further collaborate with ZAC and KU Leuven in that field. So, within GEORIS project, the partner SIJ perform also SI analysis. As you can see, GEORIS, as I said, GEORIS product developed on a laboratory scale and upscaled in KU Leuven modular unit with values which was just assumed for industrial scale production. However, when this product will go, if we will go to the market, additional SI analysis will be needed. But however, you see that we were focusing on, they performed different SI analysis, they used different methods and so on, and we were mostly focusing on how we can reduce our carbon footprint if we use those GEORIS pavers, and actually we succeeded. We reduced carbon footprint for 26%. The outcome of the SI analysis was also, it showed that GEORIS pavers has a significant lower impact for fresh water eutrophication compared to the concrete pavers. But however, we also see, probably due to the use of alkaline solution from production of GEORIS pavers, environment impact related to acidification or ozone depletion were higher as conventional concrete pavers. To conclude, let's check the video.
SIJ Acroni's approach to circular economy is grounded in innovation and resourcefulness. We're turning steel slag, once considered industrial waste into a valuable resource. The largest share of our byproducts, steel slag is now repurposed for diverse applications. Electric arc furnace carbon steel slag is used in road construction and civil engineering. Eco Minute S1, produced from a mix of electric arc furnace stainless steel slag and ladle slag, is suitable for various construction embankments. We're always looking for a new challenge and have set our sights on developing and exploring new uses for recycled steel slag. In the project GEORIS, co-founded by the EIT Raw Materials, SIJ Acroni is paving the way to a sustainable future, literally. We're applying a novel geopolymerization technology to produce environmentally sustainable construction materials. Geopolymers utilize aluminosilicate residue to create binding agents with properties similar to or even superior to conventional materials. GEORIS pavers have good mechanical properties and excellent durability. They were produced from metallurgical residues and completely without cement. Instead of natural raw materials, the mixed design developed by KU Leuven uses 78% of metallurgical residues, of which 62% comes from SIJ Acroni's recycled steel slag. Compared with conventional pavers, paving an area of 1 square meter with sustainable geopolymer pavers would save 27 kilograms of carbon dioxide. At SIJ Acroni, we established a small-scale demonstration project using low CO2 geopolymer pavers. This pilot project will serve as a test site to evaluate their effectiveness and durability over time. Living circular economy. SIJ Acroni.
Thank you.
Thank you very much for interesting questions. This presentation, are there any questions to the public? Okay, I have one question. You said you lower the carbon footprint compared to concrete. So my question is, what about economics? Very good to, let's say, traditional materials like concrete. So you use byproducts to show that?
Yeah, we also perform economics within the project. It was, it goes, but it's on the level of the highest price for the pavers. You can get it on the market, so it should be used for some niche applications, or maybe we should work a little bit more on to make a little bit more attractive dimension of it and so on. But mostly the second step is we will try to use it in another application for a bicycle sheet within the SIJ Acroni site, and later on we will see how it works.
The second question is, what kind of conditions did you use in the curing? Do you use ambient temperature or ambient? So you didn't use any higher temperature?
No, that's the advantage of it.
Okay, because if you use, let's say, a bit higher, maybe geopolymerization reaction would be better, higher strength to try with the temperature variations. The focus was to get right properties at not elevate temperature, but at ambient temperature, because if you use elevate temperature, it will increase the cost of the production, and it will also probably if you will go in upscaling and in commercial production, then I will have to have another facility to do it that way. That's why we were really focusing to produce as if it's possible to obtain the recipe at the lowest cost. But however, it's still, as I said, it's R&D product. So before we will come with geopolymerization technology, with geopolymers into the market, I think it will still be some time but hopefully it's good technology, so hopefully we will succeed in the future.
So thank you very much.